To divide complex numbers, you want to think about this in a similar fashion to rationalizing the denominator, right? So we want to make sure that since when we were rationalizing denominators, that meant that we were trying to get the radicals out of the denominator. And when we have an I in the denominator, right, I stands for the square root of -1. So we don't want to have I in the denominator because that means we have a radical in the denominator. So we want to ultimately remove I from the denominator. That may mean that you're putting I in a numerator, or it might mean that you're adding additional I's, right, or making the numerator more complicated than it was before, just like when we rationalized with the radicals, and that's okay. To do this, right, similar to how we rationalized with radicals, is we need to multiply by the conjugate of the denominator. So we are always basically multiplying by a complex number where the I terms have opposite signs, okay, from how it does initially. So again, our goal is to get I out of the denominator, and by doing so, we're still going to use the conjugate to do so. Okay, so our examples here, we're going to perform the indicated operations and write each result in that standard a plus bi complex number form, which means that we might have multiple fractions involved in our final answer, and they would be separated into the real part and into the imaginary part. Okay, so let's look at number 1. Number 1 is 8, or I'm sorry, number 5. Number 5 is 8 over 1 minus 2i. So we have a binomial, right? A full complex number with both a real part and an imaginary part in our denominator. And so we want to multiply by the conjugate of that, right? Both in the numerator and denominator. So the conjugate, we would keep the 1, we're going to keep the 2i, but we're going to make the 2i component positive so that those i's have opposite signs, and we'll multiply by that 1 plus 2i in the numerator as well, so that we're not changing the value of our expression, we are just changing what it looks like. We're multiplying by a value of 1. Okay, so how does this help us, right? What happens here? Well, when you expand the denominator, just like when we were rationalizing denominators, right? You've got a difference of squares that's going to happen. You've got 1 times 1, which is 1. Your middle terms are going to cancel, so then you only need to worry about the minus 2i times the positive 2i, which would be minus 4i squared. And again, that I squared, right, is just -1. So that means we have 1 plus 4, -4 times -1, and 1 plus 4 is 5. So our denominator becomes 5 here. The I is gone. Now we're going to simplify the numerator. We're going to distribute the 8 through the top here. So 8 times 1 is equal to 8, and 8 times 2i is equal to 16i. Okay, and then what we need to do is simplify, since we have one single denominator term, right? We're going to split up the numerator so that they're individual fractions, each with a denominator of 5. We're like uncombining like terms, like fractions, if that makes sense. So we're going to have 8 fifths plus 16 fifths I, and it's okay to have 16i over 5 or 16 fifths I. It doesn't matter. Both of these fractions are fully simplified. So this is your final answer in standard form, right? We have that real part and we have the imaginary part, and they're separated. Kind of like back in the days of y equals mx plus b, when we wanted the mx part separate from the b part. All right, number 6, we have radical 5 minus 2i all over radical 5 plus 2i. Again, we want to multiply by the conjugate of the denominator. So we're going to keep the radical 5, but we're going to change the sign of the positive 2i to negative 2i. And that's what we're going to multiply the numerator by as well, the conjugate of the bottom. And since that's a binomial as well, I'm going to group them both in the parentheses. All right, so let's take a look at our denominator first, right? Again, difference of squares. We're going to multiply the radical 5s. That would be 5. Middle terms are going to cancel. 2i times negative 2i would be negative 4i squared again. And we know the I squared is really representing -1. So we have 5 negative 4 times negative 1 is positive 4, so 5 plus 4, which gives us 9 as our denominator. And then we do have to expand out the numerator, right? This is actually a perfect square trinomial if we want to be technical about that. So we would have radical 5 times radical 5, which is 5. And then we're going to have 2, right? Negative 2i radical 5s when you look at that. So negative 2i and negative 2i would be negative 4i radical 5. And then negative 2i times negative 2i would be a positive 4i squared. So again, to simplify this, right, I squared is negative 1. So that means we really have 5 minus 4i radical 5 minus 4 all over 9. Combine my like terms, the 5 minus 4 is 1. Minus 4i radical 5, that's still all over 9. And now to separate it out into its pieces in case something is simplifiable, right? We're going to take both of these pieces of your numerator and put it over the 9. So we would have 1/9 minus the 4 radical 5 over 9, and I can put I at the end, or you could keep it as minus 4i radical 5 all over 9. I like to put that I kind of as like a separate thing for a fraction to make it look like it's coefficient, but when it's just a radical there, I like to put it before it. Just my personal tendencies, take them or leave them. And both are fully simplified. There's nothing more I can do there. So that is my final answer in standard form. All right, number 7. Number 7 is 4 minus I over 4i. And even though my denominator is a monomial in this case, pretend it's 0 plus 4i, right? We want to multiply by the conjugate, which is the opposite sign of the I term. Okay, so I'm going to multiply by negative 4i in both cases here. Now, technically, I can multiply by something even smaller. I can show you that in a second, but I just want to keep it simple for now and show you what would happen if you do need to simplify at the end. So there's a purpose to this, I promise, in case you're wondering. And then I'll go back and I'll do it a little bit simpler way. So 4i times negative 4i would be negative 16i squared. And the I squared, once again, is negative 1. So 16 times negative 1 is positive 16. By multiplying by the opposite sign for the I term, we end up with a positive denominator, which is nice. And then we want to make sure we distribute that negative 4i by both terms in our numerator. So 4 times negative 4i is minus 16i. And negative I times negative 4i is positive 4i squared. Once again, I squared is negative 1. So we end up with negative 16i minus 4 all over 16. And now I'm going to split it up and kind of switch them around, right? I want the real part first. So that would mean negative 4 over 16. Right? The second part I'm just putting first. Minus, I would have the 16i or 16/16 I, right? And then we can reduce both of those fractions, which means we should. So 4/16 reduces to 1/4, and 16/16 reduces to simply 1, right? So we would end up with negative 1/4 minus I. Okay, so when I got to simplify there, right, that does indicate, so if I kind of start this over a little bit, I told you I would show you this, which we have the ability to do when we're dealing with complex numbers, is instead of multiplying by the full negative 4i, it's really the I part that I want to cancel. So if I just multiply by negative I, this is like the case if I multiply by the smallest radical that would create a perfect square. That's what I'm doing here. So 4i times negative I would be negative 4i squared. The I squared becomes that negative 1, right? So that means I have positive 4 in the denominator. Distribute your negative I through, right? I would have negative 4I plus I squared. Replace the I squared with a negative 1, and I would end up with negative 4I minus 1 over 4. And then again, if I switch them around into the real part first, negative 1/4, you can see I came up with that first fraction simplified kind of already. It's already closer to the answer, in this case, the exact answer, than it was in the original before I did break it up. And then minus 4I over 4. That still needs a little bit reducing, but it needs a little bit less reducing than that 16/16, right? So it won't necessarily eliminate all of the reducing, but it certainly can get your answer a little bit closer to what it would be in simplest form than if you multiply by the exact same thing. So you have that option to just kind of multiply by the negative I part as opposed to bringing the coefficient with you. I just wanted to point that out. Okay, number 8, we have radical 3 plus 4I all over negative radical 3 plus 4I. And again, we want to multiply by the conjugate, right? So I'm going to kind of squeeze it in here and then I'll move down. We're multiplying by the conjugate of the denominator. So the conjugate of the denominator, remember, is the opposite I part. So negative radical 3 minus 4I is the conjugate, and that's what we're going to multiply the top by as well. All right, so let's expand this out, bringing it down here. My denominator, expand that further, there we go. Again, is going to be your difference of squares. So negative radical 3 times negative radical 3 would be positive 3. And 4I times negative 4I would be minus 16I squared. Replacing that I squared with a negative 1 makes it 3 plus 16, or 19, as my denominator. Okay, and then expanding the top. So radical 3 times negative radical 3 would be negative 3. Radical 3 times negative 4I would be minus 4I radical 3. 4I times negative radical 3 would be negative 4I radical 3 again. That's convenient. I like it when the radicals match and their terms out in front do as well, or like terms. And then 4I times negative 4I is negative 16I squared. Okay, so to simplify this top, again, I squared is negative 1, and we can combine the middle terms as well. So we would have negative 3 minus 8I radical 3 plus 16 all over 19. I would combine the negative 3 and the 16 to get 13 minus 8I radical 3. That's all over 19 still. And then let's separate it into its pieces, right? So the real part is 13. I'll put that over 19 on its own. Can't be reduced. Minus, I'll put the 8 radical 3 over 19. That also cannot be simplified any further. And tack on I after that coefficient. So 13/19 minus 8 radical 3/19 I is your simplified answer in standard form.